Okay, I want to just recommend you click on this link over here and you'll watch another YouTuber do this particular problem. I'm going to go through it though. As I go through it, certainly it's going to be a little bit different than he does it, but the bottom line is something that you're familiar with already. Now, certainly looking at these guys over here, I'm not really familiar with everything in the problem, so I'm just going to work on the top. And the top, what I see n, and then I see n squared. I'm just looking at the top, by the way, and then n cubed, and then plus yada, 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 up to n squared. And I sort of recognize this as being geometric in form. And what I'm going to do over there is going to factor the n out, because I want to get that 1. And 1 plus, that's going to be what? N plus n squared plus yada, 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 up to n to the n minus 1. I just factored out the n, by the way. So what I want to do is talk about the what I would do over here is recognize it's geometric. And again, if you can't recall, it's fine. So I'm just going to write down, what I know about geometrics, by the way. By the way, this is the top. That's all I'm talking about over here. And I'm going to write, a geometric series down for you. And I'll use the same letters. So I'll write down, this is 1 plus n squared plus yada, 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 up to n minus 1. Multiply both sides by n. And what do you get there? You would get n plus n squared plus n cubed plus yada, 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 up to n to the n. That's not so bad. And then what do? I subtract. Let's say n, s, minus n. This should bring back memories of what you did in pre-calculus. What do I know about this thing over here? A lot of cancellations when I subtract. And a lot of cancellations would happen. And what are you left off with? You're left off with n to the n. Go back to my pen. N to the n minus 1. Let me factor the s out. And what do you get? You get n minus 1 equals n to the n minus 1, or s would equal n to the n minus 1 over n minus 1. All right? Pretty typical formula that you derived in pre-calculus. And then the question is, what's s? Well, s, if you recall, it's right up here. I'll write that down for you. So what do you get? 1 plus n squared plus yada, 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 all up to n minus 1. So really what have I found? I found something over here. And let me write down what I found. That n to the n minus 1 is equal to n minus 1, right, times 1 plus n squared plus yada, 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 up to n minus 1. All right, so that's what I just found out right there. Now someone says, why does that apply to the top? I'm going to look at the top again. I'm going to start to erase things now. I'm kind of done with this. And someone says, well, I knew that formula. Why don't I just use that and not derive it? That's fine too. But let me start to erase this over here. And I want to just rewrite the top with that information I got down. Like, I think there's an easier way of writing the top down now. As I do it, though, I'm going to, again, write the top down for you. It's n times 1 plus n squared plus yada, yada, yada. This is just the top, so I'm doing. I'm looking at the top. And then if I keep doing that, you eventually get to the last term. I keep doing that, don't I? The last term, which would be n to the n minus 1. Now let me write this down. It's going to be n times. Well, I'm looking at it, and, I'm seeing sort of that. I'm seeing this over here. I hope you agree with that. And what would that equal to? It would equal n to the n minus 1 over n minus 1. So I'm going to say the top really kind of simplifies pretty nicely. All right, I'm going to write it a little differently. I'm going to write it as n over n minus 1 times n to the n minus 1. All right? Now, granted, I'm looking at that and wondering, does it really help me out? It does. I mean, I got, this is really kind of simple to look at and really take care of that whole summation thing over for me. I don't have to worry about that anymore. So I got something really simple for the top. All right? Let me point out where that's written for you. And that's written right over here. Now, if you're able to read through the work without listening to me, that's fine. Or if you're able to do it yourself, that's fine too. But that's what the top is, all right? Then it says, let's work on the denominator. And I'm going to say the top, there's not much I can do about it at this point. The top looks like it really kind of really became very simple, right? Very simple. And remember what the top became? It became this thing over here. That's the top. Now let's look at the bottom. Looking at the bottom, and you might say where these things come from. It takes maybe a hint or maybe just a lot of work or thinking about it. But what I did was I multiplied by a unitizing factor, and that's going to be n to the n over n. All right, because I'm looking around for things I know about. And when I did that, what I did was I brought the n to the n on the inside of that. So let me write that down for you. So it's going to be n to the n. And then every term I'm dividing by n to the n. So the first term would be 1 over n to the nth power. The next term would be 2 over n to the nth power plus, I think you get the idea, yada, yada, yada. Now, where's that written down? Right over here. All right, so really not much you can do about that. Well, I wrote it down twice, didn't I? I guess I could delete this line over here. I don't think there's not really much added value to that line, is there? All right, so I'm going to delete this when I think about it, when I go back to the notes over here. But, someone says, what is that giving you? I don't know. I guess I could rewrite that a little bit. N to the n. And I'm going to start here and work in that direction now. And what's that going to be? 1 to the n. Now, someone says, I wonder what the next term is here. I'll write that down for you. It would be n minus 1 over n, because I go backwards 1, right? Over n. What's the next side going to be? Well, it would be n minus 2 over n to the n. I'm just going backwards. I'm going in this direction now. Plus n minus 3 over n to the n. Plus, I think you get the idea. It keeps going on until I get to that last guy, which would be plus 1 over n to the n. All right? So I want to say that it kind of looks strange to me, but I'm going to keep writing it. N to the n. And I see 1 to the n. And the next thing I'm seeing 1 minus 1 over n to the n. And then I would see 1 over 2 over, I'm sorry, I didn't mean to put a plus sign there. I'm thinking additions when it's not an addition. It's going to be minus 2 over n to the n, and plus 1 minus 3 over n to the n, plus yada, yada, yada. Where does it kind of end out in a finite sense? 1 over n to the n. All right? So I'm looking at that, and that looks sort of familiar to me. And someone says, what do you mean it's sort of familiar? It's sort of familiar. I'm looking at that sort of familiar. I want to point out what's sort of familiar to me is these things over here. I'm seeing a structure to this over here. At least I'm seeing it over here. And what am I seeing? 1 minus a over n to the n. And I recognize this thing as a limit problem. And so I'm saying if the limit as n goes to infinity of this thing over here is going to be equal to e to the minus a. All right? So what do I do over here? I recognize that. So what I'm going to do over here is I'm going to take this and hope I see this at some point. All right? So let's point out what I'm looking at now. All right? I'm pretty clear about what I'm seeing. And I want to make sure you understand we have the top. That's right over here. I put the top down for you. Put the bottom down for you. And again, I try to get this thing to look like what I want it to look like, which is something over here. I want it to look like this over here. So I bring this to the top. All right, let me show you where that's written down now. So this is the top, and I'm taking this thing and bringing it on the top right now. I'm going to divide the top by that. And the bottom, what I'm seeing that pattern again, right? So I'm seeing this on the bottom still. And that goes to that level over there. I want to look at the top first, though. All right, the bottom I'm still a little bit worried about. So in the top, what I got, I have n, and I have, let me get my eraser out again because it's too much. I'm going to go back to the pen. It's n, and then n to the n minus 1, And what in bottom, I have n to the n, right? I see that over here, and I have n minus 1. Right, so I'm going to say, looking at that, I wrote it that way for a reason, because I'm going to have to take a limit at some point, and I got to take the limit of this thing as n goes to infinity. This looks like a really easy limit to do, by the way. And I also got to take the limit of the bottom as n goes to infinity. Right, so this is the bottom. I got to take the limit as n goes to infinity in the bottom as well. You should realize that when it goes on to infinity, that this is going off to infinity as well. There's an infinite number of terms. And what do I get? I notice over here. I notice like the first term is just 1 to the n. The next term is 1 minus 1 over n to the n, so forth and so on. And it trails down. And what do I start to notice? As n goes to infinity, taking the limit now, the top is really easy limit. And the bottom, I don't think it's an easy limit, but at least I can write it down. At least I can write that down. Now the limit of the top, I'm going to put this on the side for you. Limit as n goes to infinity. I'm going to look at the top, by the way. n minus 1 times, that's n to the n, minus 1 over n to the n. Well, this guy's limit goes to 1, and that guy's limit goes to 1. So the limit of the top is just 1 times 1, so this goes towards 1. Let me look at the bottom now, and I'm looking at it, and I'm starting to see things over here. What am I seeing over here? Well, as n goes to infinity, that's just e to the minus 1. As n goes to infinity, that's e to the minus 2. The next one would be e to the minus 3, so forth and so on. And the last one would be like e to the minus infinity, by the way. So what I want to do over here is write that down. So the top, again, is 1 times 1, which is 1. The bottom is 1 plus e to the minus 1 plus e to the minus 2. And again, I'm being in a situation where I can't do this either, but at least I'm getting somewhere where I'm getting things written down now. And that goes on forever, by the way. Let me get my eraser out, and I'm going to start talking about that bottom thing. And the bottom is a sum. And what kind of sum is it? It's a geometric sum. And I want to go through that with you. All right, geometric sum. So the geometric sum I'm getting on the bottom is going to be 1, I keep doing that, is going to be 1 plus 1 over e plus 1 over e squared. I'll write this way, plus 1 over e cubed. And that's a real simple geometric sum, by the way. What's that going to give you? Well, it's going to give you 1, and then it's going to be 1 minus the common ratio, which is 1 over e. I'm going to simplify that by multiplying the top and the bottom. Let's see if I did that right. Oh, you know what? I don't need to do that. What am I doing? It's really kind of simple now, right? Isn't it? It's just 1 on top, and on bottom, what do you get? You get 1 over 1 minus 1 over e, which turns out to be pretty simple. It's just going to be 1 minus 1 over e. Now, what I was going to do over here is just simply say this is e over 1 minus e, and the reciprocal of that is this thing over here. So we found the sum, and we're done. Is this a tough problem? I consider it to be an extremely difficult problem, by the way. All right, now certainly other people look at this and say, oh, it's really kind of trivial. I could do that in my head. People vary. This guy does a nice job of it, and he certainly goes through a similar explanation, certainly using the same type of stuff. It's stuff that you're using, what you've seen before. We use 2 big concepts, geometric series, which you should be very familiar with at this point, and the other thing is that limit that gives us e, and that's a nice thing to know about. Thank you.